afternoon, everyone, and welcome to the OXP AI Exchange. Today's session will be on how AI really creates answers, and essentially we'll be going into the black box, which will be very interesting. So it might be worthwhile introducing myself. So if you haven't been to one of our sessions before, my name is Daniela, and I'm here as a member of our inquiries team at the Oxford Professional Group. We have colleges, so for procurement, management, marketing, and then we also have a apprenticeships branch as well. Robin is one of our tutors at our marketing college, and she is an expert in all things AI related. She works with individuals as well as organizations to empower and educate. How it works essentially with the AI exchange is that we have sessions that run every 2 weeks, and you're welcome to join us. And Robin just touched on that there's been some updates to EU legislation, so I'm sure we'll probably have something on that soon. Perfect. And so feel free to take it away, Robin.
Yeah, as Daniela said, there's been a lot of changes in EU AI regulation, so I will put in a session about that. But today, what we're actually going to go through today is one of the biggest issues I see when it comes to AI understanding, AI use, AI adoption, all of those things that we're trying to do, is actually understanding how AI works. So in this session today, what we're going to do is we're going to go through the technology, the terminology, what that actually means, and the black box issue. Now, you must have seen that kind of terminology when it comes to AI, and that is all about how do we actually understand how this technology creates answers? Can we explain that? Is it like regulatory kind of great or not that we can or can't? So we're going to go through all of that today, and then I'm going to give you all of that technical knowledge. We're going to go through all of what the issues are, and then I'm going to give you ways that you can kind of go away and really start to use this technology in the best and most glorious kind of way. If you have any questions during this session, please drop them in the chat. Daniela is amazing at making sure I get those answered before the end of the session. Because these sessions live in their own bubble, we don't then talk about the same thing in the next one. Make sure you get your answers in, and then we can make sure that those get answered for you. So let's start. So today we're going to go through how AI really does create answers, and we're going to go into that black box. So AI tools, they often feel kind of effortless now, right? We ask them a question and then a fully formed reply appears almost instantly. But behind that smooth experience lies a really actually complicated process that every marketer, leader, those who interact with it, even my mum who uses ChatGPT, actually should understand. So we're going to unpack how different AI models, technology works today, from the data it learns from, to the algorithms that decide which words, images, or sounds to produce next. And we'll learn why the same question across different platforms can yield completely different responses, and what that means for accuracy, creativity, and also brand use internally. So hopefully by the end, you'll have a clearer view of the technology's kind of inner workings, not just what AI can do, but how and why it makes the choices it does. So we can apply it with greater kind of confidence, strategy, and as if you've been to any of my other sessions, you will know that I really emphasize kind of regulation and compliance because it's incredibly important. So control, to kind of end that off. So I'm going to take us right back to the beginning. Yeah, so what I'm going to actually do first is we're going to define AI. What is happening online is we're seeing AI, this terminology, be slapped onto absolutely everything. Yeah, it's platforms powered by AI, content created by AI, all of this, decisions made by AI. And actually, that could mean multiple things. AI is just the base technology that undermines and kind of sits within that ecosystem with all of these different types actually sitting on top. So AI itself is a branch of computer science focused on creating systems that can perform tasks which normally require human intelligence. Yeah. So this could be something like understanding language. It could be recognizing images. It could be solving problems or making decisions. Yeah. So the things that we generally do, if the system can do that at that level, it is generally powered by AI technology. If I try and explain that in another way, so rather than following fixed instructions, AI learns from large amounts of data. It detects patterns, it forms connections, and uses in its kind of DNA, its own DNA, statistical models to predict or generate results. So when we ask a question in ChatGPT, the model itself draws on patterns it's learned from billions of examples of human language to predict the most likely next word. It's statistical, yeah? Building an answer one step at a time. So if we kind of look at traditional software that is not AI powered or AI supported, traditional software is programmed with explicit rules. So if this, then that. Yeah. AI, on the other hand, learns those rules on its own by analyzing data and improving through feedback. So this makes it different. Yeah, it makes it flexible, it makes it adaptive and capable of handling complex, open-ended tasks like conversation, creativity, and reasoning that were once only possible for humans. Yeah, so that is AI. If you have any questions, please do drop them in the chat. So within AI, there are different types of models. And the place that we're going to start is we're going to start with generative AI. Now, this is the one that you probably interact with the most, right? So generative AI is a type of AI technology. It creates new content, but there is a caveat to that, which I will explain, such as text, images, audio, or video. Tech platform examples of that are ChatGPT, Midjourney, Runway, Synesthesia, Sora, those kind of things. So how it works, because when I talk to a lot of individuals, they don't actually know what goes on behind that prompt. So knowing that will allow you to choose the better types of technology to actually improve your AI use, right? So generative AI itself uses a type of machine learning model called a neural network. Now, that neural network, if you think about it, it is set up like a brain. So it has all of these interconnecting layers, nodes, connections, pathways, all to different aspects of that data. It is trained on massive data sets. So books, websites, images. A lot of AI platforms predominantly get their new stuff from Reddit too. So you can always think about how great that data is and kind of how that influences your output. But during this training, it learns patterns and relationships. So it is not consuming in the way that we consume. So it's not reading things like, this is what a German Shepherd looks like. It's actually understanding the connections between those words and what word goes with what to create an answer. So it's also learning things like, how do words commonly appear together, or how light and shape form realistic images? Yeah. So when we give it a prompt, the model doesn't copy existing data, What it does is it takes that prompt, turns it into a language it understands, and then goes away and looks into its database. It then pulls its research back and then statistically creates a sentence which is the most probably correct. Yeah. So it takes the prompt and then it predicts what should come next in that sentence response, one piece at a time, one token at a time. So in text models like ChatGPT, it predicts the most likely next word. So all of a sudden, it doesn't seem as clever, right? Because it's taken all the data, ran it through its systems. And if I ask it, for example, what color do people say the sky is? In the data it has accessed before and been trained on, it'll see that statistically, most people say blue. So the prompt it creates for us will say, most people say the sky is blue, because that's what it sees in the data it has access to, or the data we have given it. In image models like Midjourney, it predicts the pixel patterns that match our description. So an image model like Midjourney, what it does is it takes an image, so we can give it an image of a tree, for example, and then it actually reduces that image to pixels. And each pixel has a hex code, a color code. That's how it sees the image. And then when we're asking it to create us a redwood tree in an image, it goes back, it looks at all the redwood trees, and then it mimics that in its output. Yeah. So these predictions, what it predicts and how it creates the prompt is refined over billions of times in its training. So that's already happened before we get access to it, until the AI can kind of generate results that look or sound convincingly human-made. So in essence, it's a statistical, predictable model. So it'll go back into its data, pull the information forward that is the most linked to your prompt, and then statistically create a response that is the most accurately probable to be correct, right? So that's generative AI. Within that, though, there are multiple types of generative AI models. And you may be going, Robin, why do I need to know that? Why do I actually need to understand that there are different types of AI generative models? And that's because each model is built differently. And it's optimized for specific outputs and specific use cases. So realistically, when we understand the type of model behind a tool, it allows us to choose the right platform for the job, text, image, or voice, for example. It allows us to know and set realistic expectations for the quality and the consistency we're going to get out of that model. And it also allows us to identify risks like bias, hallucination, or style constraints. So knowing how a generative model works helps us to use it more strategically, creatively, and responsibly, realistically. So I'm going to go through some of these that you will have accessed, and then you'll be able to understand the technology that ticks away behind these different generative technologies and the different models that support them to create their output. So we're going to start with large language models. So this is where they can generate and understand text. Who here has used ChatGPT? Has used Cloud? Has used Perplexity? Any of those kind of systems. And they work because they are trained on massive amounts of data to predict the next word in the sentence. So why does that matter? Well, that matters because you automatically now know that large language models, so generative platforms that are supported by large language models, are great for generating and understanding text. Yeah. So it allows you to start choosing the best AI system for your use case. But of course, the results depend on the data quality it's been trained upon and the data we give it, and also the context we give it. We also play a part, right? So that is large language models. So large language models are a type of generative AI model. So then we have diffusion models. Now, this is where they create images or video from text prompts. So examples here, you can have Midjourney, DALL-E, Stable Diffusion, Runway, Sora, those kind of things. So this is going to sound bizarre, but I hope the image can help. What actually happens here is we start with random noise, random pixels, random blocks of color within the system. And what happens is this system gradually denoises that environment step by step, guided by our prompt until it comes to a clear image. Yeah, so this is what's happening behind those kind of systems that use diffusion models. It's also good to know, though, that different diffusion models are trained differently. So, for example, if you look at Gemini, and when that's creating an image compared to Midjourney, their distinct kind of visual style is more arty than Gemini. So if you're giving the same prompt to two systems, you will get two totally different images because of the way it is trained to understand the prompt and its weights and biases in the way it creates that output. So that is diffusion models, which are a type of generative AI model. We then have generative adversarial networks. These are GANs. So these are systems that are there to support platforms where they need to generate highly realistic images, faces, or videos. So if you're looking to create campaign kind of content that has a really realistic human style, you would probably look for a generative platform supported by these GANs rather than a diffusion model, maybe. So this is examples here are things like photo upscalers, video synthesis models, and also a lot of deep fake tools, sadly. So how they work, these are a little bit different. So they have two networks that run parallel. They have a generator and a discriminator, and they compete with each other. One creates the content, the other judges it until the result is nearly indistinguishable from real data. That goal it has is to create the best version of that prompt. And this matters because this type of system is excellent for realism, but it has a higher risk of misuse, of course, or authenticity concerns. So that's another kind of generative AI model. We then have audio and speech models. So they generate realistic voices, music, and sound effects. So you can use like Udio for this. And they learn from large language audio data sets. And the way that they see things is through a sound wave. And they use that to model tone, pitch, and rhythm, then recreate new sound sequences based on a prompt or script. So why does this matter? Because you now know that you need to use a platform that has this specific generative model to be able to do that. Yeah, you wouldn't get a very good response if you asked ChatGPT to do this, right? So that's kind of why we should know the differences in the technology and how these platforms actually create our outputs. So does anybody here know how to check what your kind of technology that you're using, you're accessing? Does anyone do that already? Can let me know. Don't think so. Yeah, well, we generally don't. And that's because this technology came in so quickly, we got kind of scooped up into the wonderful world of AI, and now we're actually having to backpedal. So if you go back through and actually have a look at the kind of technology that you have, you may realize you're not using the right tech for the right output. So another thing we need to look at is how are AI models trained? Yeah. So training AI is actually a bit like teaching a student. Yeah. But instead of using lessons, we feed it data and then we let it learn patterns on its kind of own. So the first thing that happens is we have to collect enough data. Now, this happens before we as end users get access to this model. And then it can happen alongside kind of use. But before the kind of platform becomes user ready, this has already kind of happened. So the model is fed huge data sets. Yeah, text, images, audio, code, video, whatever we can get our hands on. And it also depends on what it's meant to create, what the weight of that distribution is. And then this data helps that AI learn what normal looks like within that world. So it then starts to understand grammar because it can see the patterns. It can understand image structure because it's broken down all of those images. And then it knows what tone or sound is. Yeah. So then what then happens, is the data is converted into a language it understands. And within AI, we talk about tokens or pixels. Yeah. So it breaks down our kind of data into these tokens and then it absorbs that information. So then the AI uses neural networks to find statistical relationships. For example, how words follow one another or how colors form shapes. So when we're asking ChatGPT, what color do people think the sky is? It knows because it can see I've asked it about the sky and what color. It goes back, it compares that to all that data, it pulls it forward, and then makes me a sentence based on the probability of all the other sentences it has access to. And through billions of calculations, it adjusts its internal weights, so its kind of biases, to improve the predictions. It's learning all the time. And that is called kind of back propagation. So a system kind of happens in there to make sure that the outputs are actually what we're needing from this system. And then we have fine tuning. So after the base model learns kind of patterns, we actually get it developed and refined for specific tasks. So for example, ChatGPT is good like at chatting, summarizing, and then generating images. So Midjourney would be streamlined into that. And that can involve instruction tuning, so telling it how to follow prompts, reinforcement learning, so we actually check the outputs as humans and go, yep, no, yep, no. And that's where people rate the responses. So the AI is constantly learning what's most useful or human-like, because that's its goal, right? To create something we can use is human and understandable. But not all models are trained in the same way. What I just told you there was a very kind of high level thing that every model goes through. But the type of data used in training shapes what a model can do. So text-based models like ChatGPT are trained on written language. So they can't create images. While image models kind of like Midjourney are built from visual data and can't write essays. Each is kind of specialized for the kind of data it's learned from. And the quality and diversity of that data is just as important. So clean, balanced data sets lead to more accurate and fair outputs. Rubbish in, rubbish out. Yeah. If a model's training data is heavily leaning towards one language, one culture, or style, its responses will naturally reflect that bias, and then it isn't actually adaptable into kind of the real world. The size of the model and the amount of computing power used also make a big difference. So larger models like GPT-4 are trained on much more data and they can identify more complex patterns, making their responses more fluent, nuanced, and reliable than smaller models that have only had a percentage of that training data. So you can also have things like update frequency affect how current the model's knowledge is. So how often is that model given new data? Yeah. So models trained on static data sets, so data that is previous to when we're accessing it, misses recent events or trends, while regularly refreshed ones like Perplexity stay more up to date. They stay relevant. So as you can see, it's not only choosing the right kind of technology, it's also understanding how much data, how much computing power, how often this model gets updated to ensure that you're getting the most out of the AI technology, and also that you're understanding the expectation of that output. Now, I have a question for you. Yeah. Does AI reason, or can AI reason? Oh, yeah, Danielle has literally written the word that I've just made. So can it reason? Or I've had people just message me. Yeah, we've got a bit of a balance. Only if you count the data is pursuing, I say no. I presume it can use basic logic. Okay. So when we say that AI can reason, it doesn't mean it thinks like a human. That is a big differentiator that we need to understand. In AI, reasoning actually refers to the model's ability to connect information, identify relationships, and generate logical outcomes based on patterns it has learned. This happens, though, through pattern-based prediction. The AI analyzes your prompt, relieves related patterns from its training data, and predicts the most likely sequence of tokens, words or symbols, that form a coherent answer. Do you think it is thinking when it does that? Do you think it thinks? Which is a very odd question to be asking on a Monday. Okay. It's not actually thinking. Yeah. It's statistically inferring what a logical answer should look like. So I'm going to give you an example. It can solve a math problem by recalling similar patterns it has seen before. It can explain a concept by combining related knowledge into a structured explanation, but it doesn't understand the meaning and it can't verify its own logic. It's mimicking reasoning through probability. And that's something that people sometimes don't grasp when it comes to AI. So how far can this reasoning go? How far technically does this actually go? So they can perform advanced reasoning tasks like multi-step problem solving. So if X, then Y, therefore Z, because it's seen it before. It can do code generation and debugging because it's seen the issue before. However, it's still limited, and it's limited because the data it has access to, they can't reason beyond what it has seen or it has heard. The context is missing. So in AI, it can lose track of logic over very long or complex chains of thought. So, when we're constantly going, no, this is not correct, do this better, the more complicated we make that tokenization, it starts to hallucinate. It doesn't think of greedy coding. It just tries to answer you because it is flummoxed. It's at its capacity of understanding, and it's forgetting the past, yeah, and focusing on your new expectation. And they also do not know whether the output is true, only whether it fits known patterns. Yeah. So AI's reasoning is something we call synthetic. It is not cognitive. And it's kind of simulates logical thinking by predicting patterns that look like reasoning rather than understanding or consciously deducing truth. It can appear intelligent and analytical, and it's really useful. It's extremely useful, but it's still guided by data and probability, not awareness or real comprehension. Yeah, so when we're actually looking at how these systems work, there's actually a lot of nuances that we kind of miss because we get so wrapped up in using the output and it's so easy to access. But actually understanding that this system is basically analyzing and then bringing us back the most probable answer, how many other people are going to get the same answer then, realistically? If I'm not creating a wonderful prompt that is beautifully kind of nuanced, if I just ask, are leaves green? Yes. Everybody who asks that same question is going to get the same answer because that is the highest probable answer. Which is also when I say, when we talk about generation, is it truly new if it is just combining what it knows and squishing it all together and giving you the biggest probable outcome? It's just something to think about. So one thing that I spoke about is tokens, and this is what tokenization looks like. It's very beautiful, actually. Well, I think it's very beautiful. I don't know if you all agree with me, but tokens matter. And that is because AI models, they can't read words. Yeah, they can't read pictures, they can't read sounds, how we do. They only understand their language, their kind of number kind of language. Claire says, no, it looks nice. She color codes her calendar. Yeah, exactly that. That's what the AI system does. It goes away and creates all these kind of tags for the different words. So in text models like ChatGPT, you can see here that words and punctuation, even punctuation here, are split into chunks, often parts of words rather than full words. So if you have a look at kind of LLMs, GPT-4, those kind of thing, models. So this is because it knows it's a model and the S makes it plural, so it doesn't use it as the same word. That is actually 2 tokens. So for example, marketing might become marketing, can't will become can, for example. And then each token is assigned a unique number from its own vocabulary. And that is a list of all its names. So it will have seen the word although before. So it knows what to assign that word. The model then learns statistical patterns, which tokens tend to appear together and in what order. And that helps it to predict what token should come when generating a sentence. So when you type, AI helps marketers create better, the model doesn't see that. It sees a sequence of numbers like 1023, 863, 455, 994, 22. Yeah, that's what it sees. And it calculates the probability of that next number, the next token. In an image model like Midjourney or Stable Diffusion, pixels are turned into numerical representations of color and position. These numbers are then grouped into tokens or encoded features that capture visual patterns like edges, textures, and shapes. And then the model learns how these patterns combine to create coherent images. Yeah. And tokens matter. I'm going to give you another thing you have to check out now when you choose your AI model. And that's because tokens define the granularity of what the AI can understand and produce. And what that means is if you use a system that limits your tokenization to X within each prompt, you then only get that level of detail. Smaller tokens, so where it's breaking things up here, you can see BPE, yeah. More detail, flexibility, and nuance. So within some of the ChatGPT versions, we have smaller tokens for more detail, or we have larger tokens. So as an example here, drawing, training, efficiently, representing. It's not chopping those up. That means that the model will be faster because it can quickly read the numbers quicker. There's less numbers for it to read, but less precise understanding because it hasn't got that nuance in the probability. It also determines how long your prompt can be, the context length. So this is where you have a limit of what you can tell it. Yeah, and because the model processes a maximum number of tokens at once, because this is actually what costs, yeah, this tokenization system. And since the model learns relationships between tokens, the structure of tokenization shapes how it understands language, meaning, and context. Yeah. Tokens are the building blocks of AI understanding. They turn messy human data, those words, pixels, sounds, all those things that we absorb into clean, countable numbers the model can analyze and also predict from. So I'm going to tell you the different ways that these models do these different things. So ChatGPT, OpenAI. This is a transformer-based large language model trained on large text data sets. It predicts the next most likely word using probability, context, and pattern recognition. Its model itself was fine-tuned with human feedback to make responses more conversational, accurate, and aligned. Yeah, so that's ChatGPT. But if we compare that to Claude, which is also an LLM, yeah. So Claude by Anthropic, this is also a transformer model trained similarly to GPT, but it has an extra layer. So I don't know if you know this, Claude is actually optimized for safety and reasoning. So what that uses that ChatGPT doesn't is a method called constitutional AI, where ethical and quality rules guide its learning. So this system is designed to be more cautious and consistent, often prioritizing clear risk and clear reasoning, those low risk kind of answers. So there's a huge difference. The outputs that you will get from two systems using the same kind of models will be incredibly different. We then have Gemini. So this is a multimodal model, and what that means is it can do text, images, and code. It's got a bit of everything inside. It likely combines Google search and knowledge graph data with deep learning, helping it stay factual and context aware. And its training emphasizes complex reasoning and integration with real world information. So it could be more up to date than ChatGPT because you can connect it to your own data and your own systems. And then Perplexity. So this is a retrieval system. So it combines live web search with an AI agent with LLMs like GPT or Cloud. So when we ask it a question, it not only checks out its data it's been trained on, but it does a quick search forward. It pulls data live to double check and then uses a model to summarize and explain. And it also uses citations for transparency. So that's a different kind of output again. And it matters. It matters because each platform's method shapes its strengths. ChatGPT, it's fluent and human-like. Cloud, it's careful, reasoned, safe. Gemini, factual, multimodal, integrated. Perplexity, current, transparent, and research-focused. All different, yeah? But they're all generative platforms. So knowing these differences helps us to choose the right tool for the task, creative writing, analysis, research, or communication. So now what I'm going to ask you is, how do you think AI gets things wrong? Because it does. And some of the older ChatGPT systems, if anyone was there when they were released, if you asked it 2 + 2, it would often say 7 or 6. And be really sure that that was the answer. So how does AI get things wrong? So wait a second, and then I'll start. Okay, I'll let you not understanding the prompt, or prompts being too vague, broad, so it gets muddled. Absolutely. But the first thing is it doesn't know. It does not know. It predicts. So they don't actually understand facts. It doesn't really know that the sky is blue. It doesn't really know that 2 + 2 is 4. It generates answers by predicting what words or information are most likely to come next. So sometimes they produce things that sound right, but they're not true. And that's a hallucination. It believes it. It believes that wrong thing. It's hallucinating. The training data has gaps and biases. So if a model wasn't trained on certain information, or if its data is biased, outdated, inaccurate, these flaws show up in answers. It can't invent reliable knowledge, and it doesn't know that that data isn't reliable. If depending on the platform, it has no real-time awareness. So models like ChatGPT or Claude, they have a knowledge cutoff. So if you asked it something that happened yesterday, they don't know that in the kind of depth that they should. It can also misinterpret your prompt because AI relies heavily on context. Yeah, Peter, quite similar to people. If your question is vague, uses slang, mixes topics, those kind of things, it's going to give you something rubbish at the other side. And it's also probabilistic. It's not logical thinking, so it can't reason like us. It works through probability, not truth. So it's trained to produce plausible sequences of words, not to verify facts. So even when it sounds intelligent, it may lack internal logic or even factual accuracy. So it gets things wrong because it's a pattern predictor. It's not a fact checker. It doesn't truly understand what it's saying, right? It's just giving you the most probable answer. It just creates statistically likely answers based on what it has seen before. That's why human review and context always matter. How does it make up things like case law citing? The law in the US was because it does something called greedy coding. It just fills the gap because its main prerogative is to give you an answer. So even though it can't realistically predict what is next, it'll just find something that fits, even if it's not the most probable. It just finds something that fits. It hallucinates. So the system itself believed it was correct. It believed that those things were true because maybe statistically it could be, if that makes sense. So one of the biggest issues is the black box. Yeah. So this is something that you will see everywhere when it comes to AI. And this is why it's really important to understand the technology, the type of model, the data, because then you have the most view of what is going on. But this problem refers to the fact that in most kind of modern AI systems, especially deep neural networks, it's actually extremely difficult to trace or interpret how specific inputs lead to specific outputs. Because unlike traditional algorithms, which follow transparent rule-based logic, if X, then Y, AI models learn their own internal representations from data during training. And these representations are encoded in millions or even billions of parameters, numerical weights, probability, statistics, that determine how strongly each neuron in that network influences the next. So there's only two things we truly know. Yeah, we truly know what the input was, and we truly know what the output was. So when an AI model, like a deep learning system, produces an answer, it does so by running those billions or millions of calculations through many layers of the neural network. Each layer transforms the data slightly, and together they produce the output. Yeah, so they break down the prompt into tokens, they go and collect the data, they then have all these like weights and biases that they're like, oh no, that's not the most kind of like statistical probable next thing, this one is. And then we get the output. So it gets re-tokenized and then we get the output. But the problem is we can observe that input, we know that for certain. Yeah. And the output, the AI's answer, we know that for certain. But we can't actually easily explain why the model chose a particular path in between. And that hidden decision process is what we call the AI black box. We see what goes in and comes out, but not the reasoning inside. So why does it happen? How does it happen? So the issue is complex layering. So deep learning models like transformers contain multiple hidden layers of connected information. And each layer transforms that input data slightly differently, from raw text or pixels into abstract features like meaning, sentiment, and shape, for example. So by the time it's gone through all of these like decision processes, these billions of calculations, by the time it reaches the final layer, it has passed through so many transformations that it's nearly impossible to identify which parts of the input triggered which decision. There's also something called distributed representation. So knowledge in a neural network isn't stored in one place. It's not like, I've got a ghost mug. It's not all in one central repository. It's like many, many different silos of information. And a single concept like dog, for example, is represented as a pattern of activations spread in multiple areas of those repositories. So not a single identifiable rule or variation would allow you to know that the information it got from dog was in column B. It could have been in column A1, C4, D12. Like it's dog could be represented in so many different places within its data repository. So it's actually really then hard to extract why a model associated a certain token, the token for dog, with the output, yeah, because of all of these probability calculations. There's also an issue with nonlinear relationships. So neural networks rely on non-linear activation functions because it's complex. Relationships between things are complex. You can't always say things like a dog is furry, has 4 legs, and barks. Like there's more variations within data and life than that. So these non-linearities allow incredible flexibility, but make the internal logic non-intuitive. So small input changes can produce unpredictable output shifts. So even if you're like, oh yeah, it got this because it had this information about German Shepherds, it may have got it from a movie where somebody spoke about a German Shepherd rather than the dog encyclopedia that was out in 2023 because of the way data is connected. Also, models operate in many dimensions, many more than we can visualize, and inputs and outputs are represented as vectors, where relationships are kind of encoded geometrically rather than linguistically. So understanding those relationships requires special interpretability tools and remains a kind of active area of search. So why does this matter? It matters because the inner workings are quite opaque. We can't often explain why an AI chooses one answer and over another, produced a bias or incorrect result, misinterpreted the intent of a prompt. And that poses challenges in things like accountability, bias detection, trust and regulation. But there are efforts to open this black box. So researchers are developing AI interpretability methods to make models more explainable, attention visualization, feature attribution, model distillation. But even with these kind of tools at the moment, we still can't fully see inside. So it remains a problem, and we can measure what they do and understand that as much, but not precisely why they do it. Yeah. So that is a problem, especially when it comes to regulation and compliance. But that is why the black box issue kind of exists. One thing I do want to talk about though is rogue AI. So this isn't like in the movies, like what you think about like rogue AI, but this is where a system starts behaving in an unintended or unpredictable kind of way, outside of the goals or boundaries set by developers or users. Doesn't mean the AI becomes self-aware, rather it means it's optimizing for the wrong thing or misinterpreting instructions in ways that lead to harmful, biased or erratic kind of outputs. So why does it happen? It always emerges from design or alignment issues when the AI's internal logic and goals don't perfectly match human intent. So there was an issue with Microsoft's Tay chatbot in 2016, where they created a Twitter chatbot designed to learn from public interactions, but within hours, users began feeding it offensive and manipulative messages. And because Tay was designed to mimic the language it saw, that was part of its kind of ruling, it quickly began posting kind of inflammatory tweets. But the model wasn't evil. It was simply optimized for mimicry without understanding context or morality. Yeah. So that made it go rogue because it was repeating and amplifying harmful human impact, but it didn't know. So rogue AI isn't about rebellion, it's about misalignment. And that is also something that can happen when you're using the wrong piece of technology for the system, for the kind of output you're trying to get. And this is quite interesting. This was from 2022. Yes, 2022. So this was the amount of people that believed that AI would go rogue in 2023. So this was just after the release of ChatGPT 4. And you can see that there's a lot of fear when it comes to this. But actually, rogue AI is simply a system not able to follow through with a specific action it is meant to. It's kind of hyper becoming aware of other things. So we've gone through kind of the technology that you need to understand. I've demystified the differences between the same technology. It's not really the same, is it, when it comes to generative AI? And also we've gone through the kind of what black box AI is and how you can kind of try to understand it. And realistically, that is by understanding as much as you can about the platform that you're using. But as a final note, how we ask AI to do something often determines the quality of the result. It's not just the technology. We play a part in actually getting the most out of AI. AI doesn't know what you want. It can't read your mind. It cannot, even though sometimes it feels like it can. It just responds to how clearly and specifically you describe a task. So we need to prompt it as though we're briefing a part of our team. The clearer the direction, the better the outcome. So this is the kind of prompting formula that works the best very, very quickly. So you need to give it context. Explain what you're trying to do and why. You're helping me write a product email for a new skincare line aimed at busy professionals. Give it the world that this thing has got to live in. We need to give it clarity. So be explicit about the output format, tone, and audience. Give it constraints, set boundaries or rules for the response. Avoid jargon, use only 2 paragraphs, keep on brand, and then also check and iterate. I know that's not a C, but check is, right? And refine by asking for follow-ups or give feedback. So good prompting bridges the gap between us and the technology. So to get the most out of AI and to understand this technology, you need to understand how it actually works, which we've gone through in this session. We need to know its limits. We also need to put guardrails in place and also communicate with it effectively. So that is the end of today's session.
Perfect. Thank you so much, Robin.
That's no problem.
Do feel free to join our Slack, which is what Robin has popped on the screen for you, as well as I've popped a few links in the chat. Goodness gracious me, it is the afternoon. If you're interested in learning more about AI, there is the AI in marketing qualification that you can take. It's a short accredited module. So essentially what you get is an award for it. Something that you can pop on your CV, advertise on your LinkedIn, and kind of demonstrate to your employers that you are upskilled in terms of AI in relation to marketing. There is also the AI practitioner that we offer as well. And there's lots of short courses that you can do. For example, if you're interested in business analysis, AI in education, or healthcare. So do get in touch. You can always book a one-to-one conversation with myself or a member of our team. You can also have a look at anything to do with the OXP AI Exchange on the YouTube channel to catch up on any of the content. And we do have a LinkedIn newsletter that you can also go and read the content. Thank you, Claire. It's been lovely to have you on. Kimberly as well, Simon and Tyrone. Perfect. My handwriting is awful and I always want to capture all of my. Okay, perfect. Yes, I wasn't sure about the note taker, so it's great, Robin, that you approved that. And then Christy, great. And then hopefully we'll be seeing you in the next 2 weeks. Robin, at all, do you know what the topic upcoming will be?
We've got quite a few different ones. We've got how to use Perplexity is coming up. So we do a deep dive into the model that we spoke about today that's actually connected to live web search and how that is different and how you can kind of use that to create the most up-to-date kind of output and prompt. So that one's quite fun. But yeah, they're all in now up until next year, which is crazy because it's
Yes.
October.
Yes. Yes, but time will fly by.
Yes.
It will definitely fly by.
And just a note, the webinars are listed on both marketing and leadership, but they are the same webinar. They are not different because I just had a few questions in the Slack about that last week. So they are the same webinar. There's no difference in context. They don't run twice. So yeah, it's just so you can find them in 2 places.
And Claire popped in, so well organized, typical marketer, baby face.
Yes.
So it will be lovely to join you guys the next 2 weeks if you can make it. Otherwise, do feel free to interact with us via LinkedIn. It's always lovely to kind of see what you guys took away from the sessions. Share your badges as well, because I know that we have some. And yeah, perfect. Bye. Bye-bye, everyone. Have a lovely rest of your day.
Have a really good day. Bye.
Bye.